Hello everyone. Today I wanted to do something with science, as I do love some good science, some fun science. And I just wanted to play around with pH indicators. So that's what we're going to do today. I've got quite a number of things to test out. So we've got these drops to use. I've got sugar over here. I've got coarse sea salt. Got vinegar. I've got Splenda, hydrogen peroxide. This is only 3% though, so not the real strong stuff. 91% isopropyl alcohol. Baking powder. And baking soda. And finally I have water. Nothing fancy. Alright, so like with anything, we probably ought to start with some labels. So I have things to test. I have sugar. I have sea salt. Vinegar. Let's see. I have Splenda. Well, I have the generic version of Splenda. But hey, it's the same stuff. Let's see. H2O2, hydrogen peroxide. 3%. And isopropyl alcohol. And let's see, I also have baking powder. Oh dear, I put these next to each other. This is not good. And I ran out of medicine and measuring cups, so we're going to use a little glass bottle, I guess, with the baking soda. But that's okay. There we go. Alright, so there are all of our labels done. Now I have to get the same amount of liquid and everything. You do want your measurements to be as accurate as possible, so anything that I'm going to dissolve, let's see, what do the instructions say on this? Apply 1 to 2 drops of pH indicator per 10 milliliters, and this goes up to 10 milliliters. Well, it's pretty small. Let's see, what does that look like in each of these? Because I might do 20 milliliters. Alright. Always miss doing science experiments when I'm not teaching, so. think that's enough to be able to see with. We'll do 10 milliliters each. No, I'm not planning on drinking from this bottle after doing this. Too much. Is one thing. Do not crisscross your food and your science experiments unless you are doing food only science experiments. In which case, too much again. Good. Here we go. So, basically went around my house and said, alright, what are some things I could test the pH for? That, some of which I've done in a classroom setting, and some of which I haven't. There's cat hair. Excuse me while I grab that. Don't know how that got in there, but who knows? If you have cats or any shedding pets, you know how it goes. Have plenty. Now, and it's just water, so. But some of these I've tested. Now, there's some stuff in that I usually use in a classroom setting that I am not going to use here because I am recording in a closet and it does not have the ventilation I would want in order to test things such as ammonia and bleach, which, by the way, don't mix those, please. It creates a very dangerous gas that will knock you out and can kill you. So, but even on their own, they are very strong smells and can be very unpleasant and not super safe in very enclosed environments. So, we're not going to be doing that. Alright. All my liquids, which I just realized I don't need all those liquids. One moment, please. Don't need that. So H2O2 goes back in this bottle. Isopropyl alcohol goes back in this bottle. I'm talking too much. I forgot what I was doing. Vinegar is already liquid. And any of the others, sea salt, sugar, Splenda, baking soda, baking powder. Oh, I forgot to do the baking powder. Mistakes can be made. There we go. And fixed when you're just dealing with water. So it's always a nice thing. But I am not gonna do all of them. I don't think I've done the sea salt with water before. I also have not done the sugar. I've done the vinegar. Probably not the hydrogen peroxide, but you know, that's the fun of things. Let's see. Let's do the vinegar. So this is just rare-rolled vinegar. It says 5% acidity. Let's see what that actually ends up meaning, because I am not sure. Okay. There we go. Vinegar goes in there. I used to do these with my students. I actually had to put containers over whatever cup was containing the ammonia, because it was such a strong smell even with the ventilation on. So, you know, that's how that goes sometimes. But that's okay. And then sometimes I would also do that with the bleach most of the time too. But I don't have to do that here. Might smell a little bit like vinegar, but vinegar is not too bad. Alright. So I'm going to rinse out the graduate cylinder after using each different liquid, just so that we don't have too much cross-contamination there. Alright, hydrogen peroxide, let's see, 3%. You can get stronger stuff, obviously, they use that, but this is what you generally can get at the store. Now, the stronger stuff, if you're careful, you have to be kind of careful with this, but you can use the stronger stuff to have a stronger elephant toothpaste reaction, which is quite fun. Let's see, H2O2. Okay, I'm off to rinse. Okay, let's see, isopropyl alcohol, rubbing alcohol. Don't drink it. So whenever I would do this, we would talk about isopropyl alcohol or rubbing alcohol, the kids would always be like, "Can it get you drunk?" No. This will not get you drunk. Wrong chemical. Oh, this one's not open. But that's okay. Let's pour that in there. Perfect. Alright. Now that one smells strong. I've heard a rumor that if you smell isopropyl alcohol while you're really nauseous, that it helps. I have no clue if that's true or not. But, oh, maybe I'll try it if I get nauseous. Okay. So then to keep things fair, we're going to use a 1/4 teaspoon for the different materials that need to be dissolved. That way they're all the same amount, at least as close as I can get it. So sugar first. All right, this is a really big container. 1 second. I can't move this because it's just really big. Sugar. Let's put that in there. I do have some stuff to stir with. I will deal with that in a little bit. Wipe it off using paper towel. Sea salt. We'll see if this dissolves in that much water. It may not. Sometimes it won't. Now, I don't know if that picked up on the mic, but the Splenda fizzed when I poured it into just plain water, which is interesting. I might have to experiment with that, but first we'll find out the pH. I have to admit that's a bit odd. I don't think I've ever seen Splenda or heard Splenda fizz when I add it to a drink. So why would it fizz when added to just plain water? Interesting. Okay, well, something to look into. Always love to find out new things. And okay, don't mix these up. Also, don't mix these up if you're ever cooking. Done that before. I don't remember how we did it, but when I was a little kid, I mixed up baking powder and baking baking soda, making some cookies with a friend, and let's just say those cookies turned out looking a little bit weird. They were extra puffy. Now, I'm not enough of a cooker to know what that means, but so baking powder. Alright, baking soda now. Wipe off the spoon for baking powder. Okay, this might get a little tricky because I don't have a bigger container for this. Okay, there we go. What was in that other container? Alright, you know what I'm gonna do? I'm gonna do just plain water. Let me get out a container. Okay, so this is, I just rinsed it, it's just water. So I'm going to use this container. It's one of the smaller ones I have in here, just with the regular water. Because that is just a little weird that's reacting the way it did. At least as far as I know. But you know what? I don't know everything, so that's okay. Never have claimed to, never will. Alright, so we've got just plain old water. Just good old H2O. Now, any of these need stirring? Yes. Okay, so I'm at home. I don't have any proper like stir sticks or whatever for like you would for a lab at school. So we're just gonna kind of stir up the sea salt a little bit. It may not all dissolve in this amount of water. That's all right. Stirring helps. Yeah. I don't know that the sugar needs it. Let's see. Oh yeah, it does. All right. Other end of the knife. Maybe. Spilled a little bit. Okay. That knife has been used on both sides. Gonna put it aside over there. I don't actually think this one is gonna need any. Yeah, that dissolved almost instantly. So odd. Alright. See, sea salt, sugar, the baking powder. Oh, now look at that. This almost looks like. Does this have a full-on chemical reaction and create something at the bottom? What's going on with this thing? Alright, well, this was one that fizzed. Let's see. This is the baking powder. I would need more water in that one. And I don't have anything to mix the baking soda with because it Okay, so I have the pH indicator drops here. I don't have the pH strips, so we're just going to do the drops. Oh, this had a, look at that, it had a container I could have used for the baking soda. Oh well, I'll have to remember that. Okay. So, apply 1 to 2 drops of pH indicator per 10 milliliters. They all have 10 milliliters. Let's see, mix well. Should change color instantly. Match the color against the color chart. Alright, so now this isn't quite, well, this is true. The pH scale ranges from 1 to 14. However, this particular indicator only goes from 2 to 10. So let's just see what happens. Interesting. Yeah, do not drink, do not get into eyes, do not set it on fire. Let's see what it's got. It's got ethanol, methyl red, that makes sense, and phenolphthalein. All those make sense. Okay. And none of those you want in your eye. Okay. So. 1, 2. 1, 2. Interesting. Okay, vinegar should definitely be a different color. 1, 2. Yeah. Now this vinegar was the one that said 5% acidity. That's pretty red for 5% acidity. That actually, well, we'll let it sit for a minute. Now, I don't know how well it's going to work with the baking powder, because it did say that the solution needs to be clear. So we'll see what it does. Baking powder. 1, 2. Splenda. 1, 2. 1, 2 for the hydrogen peroxide, isopropyl alcohol. 1, 2. Oh, now that's interesting. So that's likely an indicator that this pH indicator, the liquid is denser than the isopropyl alcohol, but not denser than anything else in here. So that is very interesting. I didn't expect that. Probably should have. Alright, baking soda. 2. Oh, that looks cool. Alright, and then this is the water. Just plain old water from the same thing that we used. 1, 2. Alright. So, let's see, the sugar is right at like a 7.6 maybe, or almost an 8, so it's basic, not strongly basic. The sea salt is actually a little bit less basic, so I would say the sugar is closer to 8, The sea salt is closer to 7.6. Now, this is where things get a little weird. I don't know how well this color is picking up on camera. It's actually quite pink, which is not on the chart. So this is vinegar. It's a 2 or lower. I would need better test strips for this that went below a 2. So, and that's always something that my students don't expect, is when they test vinegar, which is something you can eat, or lemon juice is also something you can consume, that they are super acidic, because we always think of acids, very strong acids, as dangerous. And some of them very much are, but some of them not as much. Okay, so this really didn't want to mix up. Baking powder. Huh. Oh, interesting. So the baking powder is kind of like a 6.4 to a 7. It's almost neutral. Did not expect that. Now the Splenda. Let's see. The Splenda is 7.6. So the Splenda and the sugar are almost exactly the same. Interesting. Now the hydrogen peroxide is not quite as pink as the vinegar, so it is closer to like the actual 2. But let's see, is that showing up? Kind of. Okay, so this one's gonna have to be mixed up because it just went to the bottom. Come on. Yeah, the isopropyl alcohol is a lot less dense apparently than the pH indicator. Okay. Yeah, there we go. That's more accurate. So that is more like a 4.5 or 5. It's acidic, but not as strongly as the vinegar or the isopropyl alcohol. Okay, this one needs a cap again. So this is cool. It's hanging out at the top and looking nice and dark and green. So, and kind of like a pretty blue green, but it doesn't want to mix. So let's fix that. Wish I had some toothpicks. That would have been perfect. Unless they were the ones with dye, and then it's not perfect. Okay. Oh, that's cool. So that is probably somewhere between 7.6 and 8. Very nice. Now what I think is most interesting is the actual water itself is not truly neutral, which actually tends to be the case. It's not bad or good unless there's something dangerous in the water itself. Most water's not exactly a 7. This one's probably pretty close, though. It's either a 7.6 or an 8. I know that there's been some health people that say, you know, buy our water because it's more basic, or buy our water because it's more acidic. I'd have to see the research on it. Honestly, you just ought to drink water. Let's go with that. Okay, so I have my lovely spread of colors here, and I did want to do one more thing, because you know what? It's kind of a fun thing. I brought a plate because this could get messy, although thankfully I didn't use large amounts of stuff. So let's move everything off to the side. If you've noticed which ones I've kept, you probably know what I'm gonna do. Okay, so I still have vinegar. I still have baking soda. Well, if you ever were one of those kids that made a volcano in school, or just had a teacher that was like, cool, let's mix these, or you just did it at home, vinegar and baking soda should react to each other unless there is something seriously wrong. I am kind of curious to see what happens to the pH when I do this, because we have basic and most definitely acidic, which is one of the reasons they react the way that they do. So let's just see. Love that sound. Now, what's interesting here is this reaction has actually ended up just slightly acidic, but it is pretty close to neutral. Not sure how well that's picking up, but it's pretty close. It's between the 6.4 and the 7. It's a little darker than the 6.4, but it's pretty close to the 6.4. So there you go. Now your results would change depending on the amount of vinegar and the amount of baking soda, but that is a fun reaction to do, and I do love the sounds it makes. So much fun. Thank you for watching, and if you liked this, go ahead and subscribe. I may do some more science shenanigans with ASMR on here, because I do love some science shenanigans. So bye guys.